One of the things that is so exciting about what we're seeing today is that innovation can come from anywhere, right?
A lot of the innovation used to happen within enterprise IT. Now a lot of the innovation is happening at the edges within the consumer and customer spaces.
The average enterprise today has massive IT budgets, but 80% or more of those budgets go to keeping the lights on, not to making anything interesting or new. We're turning that on its head.
Getting IT right is one of the most important things in financial services at the moment.
IT has to transition from being a roadblock to innovation to being the on-ramp for innovation.
Well, I think this is an incredible time really for technology. The convergence of software-defined infrastructure together with the reshaping of the applications really make it a unique time to be looking at how data centers perform today and how they're going to perform in the future.
This is really what I would say a evolution that's taking place in the IT industry, and particularly within the application and software engineering space.
You have to have a technology platform that can move much more quickly itself. And that's what we're seeing starting to emerge in the marketplace.
The thing I always equate it to is back in the 1800s, where it would take you anywhere from 2 weeks to 2 months to go from point A to point B. Nowadays, our customers are expecting us to turn around products quickly and effectively, similar to what they get at home or in the consumer landscape. There's so much more of a demand to deliver quicker, faster, better, that cloud computing is really an enabler for that.
So we're here to talk about the Enterprise Leadership Council and the reference implementation that's been brought together by the members and the vendor community for IT as a service. And I think it's worth noting that the Enterprise Leadership Council, or the ECLC, is an organization that came together for a very particular purpose, and that's to enable a IT transformation to a model that would increase productivity and lower cost. So let's get into the actual reference implementation, and along the way, as you're demonstrating it, maybe we can tie back some of what's been built and what is being shown to the requirements that originated the project in the first place.
Sure. What we actually have in the reference implementation, there's a set of sample applications. One of them is a trading application that actually represents kind of a prepackaged trading app that a bank would use, right? Or that they would resell to their customers or hedge funds. And one of the important things about that is those types of applications are typically quite complex, right? Many different components doing different things, low latency market data feeds coming in, queues of messages, job execution engines, portals for the users. If you look at the speed problem, it actually comes up in two completely different ways. One is just how fast can I deploy that application and get it out there, right? Because if developers are going to be working on it and trying to make it the best trading application out there or reacting to bugs or problems, they need to be able to quickly deploy that complex app in a repeatable way, right? So that's the traditional, agile development, DevOps automation. And that's one of the things that we'll show. But the other one is, to the discussion that we had previously, there's a case where we need to map this application to the best infrastructure for the particular time that we're deploying it, right? So if we're deploying it in a dev or a QA environment, all we need to do is get it up in a reasonable amount of time with a reasonable amount of performance, right? But if we're deploying it in production, then we probably need to be as close to the client with as low latency, right? So we might want to run it on the fastest kit with the best networking implementation, with the fastest routers.
And you might have a different database in production than a data store that you're using earlier. You may need HADR in staging. You may only need HA earlier. I mean, who knows what you need, but the point is it's going to be flexible, it may change, and it's different depending on the lifecycle stage.
That's correct.
Cloud computing is a means to an end. It's not the end in itself. We see cloud computing as a way in which to implement our desired operating model.
Nearly everybody that we speak to has a desire to end up with a hybrid cloud model. What everybody wants is contestability. So the choice to be able to match workload with characteristics of platform.
The enterprise cloud operating model is a set, multiple suppliers of internal and external services delivered via an IT internal service broker directly to the business in the form of self-service.
Instead of being the builder of tin, we are now the broker of IT services that we provide, that we purchase or lease or hire from one or other companies.
If I bring this up through our release management, one of the things you'll be able to see is that for this application, it's a trading application called TradeWeb. It's basically a example of an application that you would use inside of a bank or an investment bank for actually doing stock trading. It has a lot of various requirements, including taking in market data, executing jobs, portal front end for for users to interact with.
Okay.
But fundamentally a trading app.
And let's be very clear what you mean by application, because we talk a lot about application centricity, applications are what matters. But when we're talking about application, we're not talking about a very simple matter. We're talking about a complex set of virtual machines with different tiers, database, web tier, et cetera, right? All the way to the code that runs on it.
That's true. Although you could go back to the extreme example where what if we could take all of those things and collapse it all into one, where it wasn't a whole bunch of VMs, it was actually everything's running on a single VM, right? Maybe that's what you want to do in a dev environment, where you just want to spin it up real quick just to see if it works, right?
In old traditional models, the infrastructure was really the foundation for how things happened within IT organizations. Now really it's becoming a much more application-oriented world where applications and the capabilities around applications are really driving the infrastructure architectures that are enabled with or are needed within the enterprise, and that's really being driven by the customers.
Really, it's about getting IT out the way. We want to give the power back to the consumer in much the same way as the consumers are now used to using IT, as in they just go buy, get, and it works. That's really what we're looking to for enterprise IT.
With the regulatory changes that have happened since 2008 and the credit crisis, all of us are basically under the same pressure, and the cost of IT has to come down. The only way that can happen is if we automate as much as possible of our infrastructure and even our application development. So automating the software development lifecycle has become as important as the ability to provision and deprovision virtual machines or thin provision storage or automatically provision network, for example.
The buyer has made a decision. The buyer has decided that they no longer will be locked in to one provider, whether that's in an IT outsourcing contract or whether that's through some kind of locked-in capability that doesn't give them choice.
Application guys now need to start thinking about this service-oriented future, and that it's the business that's service-oriented. It's the supply chains of the business. It's the decisions about what businesses you're in, what businesses you're not in, that is really driving the service-oriented outcome, I think, across our industry.
When you're thinking about cloud, it shouldn't be just for bringing down cost of existing systems. It has to have a stronger business purpose, which is to accelerate the ability for the business to introduce new products.
So here you can see we have an application. It's actually broken up into, there's a development, a QA, a staging, and a production environment. And at the highest layer of abstraction here, we're just actually seeing little boxes that indicate, here's the app, here's the version, and here's its status, right? And I can take this application and promote it from a dev environment to, say, a QA environment, just simply by dragging and dropping that.
And what's happening there?
Whenever I do that, it'll actually create a new deployment that we can basically use to deploy this application. That will actually go out and build, a whole bunch of servers, connect them up, build, let them start up in a specific order, online them services, validate the services work. And then once everything is up and going, it'll actually open up the firewall ports and allow users to come in.
So when you say build, this is what we're talking about when we talk about automation and software-defined data center. Build meaning not it's triggering a request for someone to build it, but it's building it all the way down to the software-defined storage, where it might be carving out storage, to the software-defined network, where it might be creating something that normally would have to be done manually.
That's it exactly. And so if I come up to a slightly different view, here you can actually see, we'll switch out of the release management and we switch into a different view where we can actually take a look at the actual blueprints that build this architecture.
So what do you mean by blueprint in this context?
So we're basically taking a blueprint for an application and we're looking at which environment do you want to deploy it to, which cloud provider, is it a dev environment where maybe, being able to build it up is more important than being able to scale it up or high performance. And we actually, subtly tweak the application for, for that environment, for that particular use case that we're trying to do.
So a logical representation of the underlying platform that the application ultimately resides on, that the code resides on to create an application. That logical representation, when it actually is instantiated at one part of the software delivery lifecycle or another, could take a very different form.
That's right.
McKinsey believes that cloud is truly transformative, right? That oftentimes we see people take too timid or not aggressive enough steps to be implementing it, right? So they'll implement a system in a small portion of their infrastructure and say, haha, I have a cloud strategy.
The evolution that we're under is something that you have to go all in on. It's not something that you can chip away at the edges. So if you're going to be bold, there are big investments or big bets you need to make in how you develop applications, how you look at your infrastructure, and more importantly, how you actually are going to deliver software on a global scale.
But the fundamental characteristics of the end state that everybody's aiming toward is very consistent, irrespective of industry, irrespective of client.
This has gone from an interest, a vision, to a mandate. And now that there's enough proof points in the market where several have done this with spectacular results, there's a flood opening up. There'll be no enterprise left on earth or government that won't operate in this manner fairly soon.
So here we have some examples of this actual stock trading blueprint. And here you can actually see a relatively great example of, we actually have a blueprint here that mandates that you must deploy it to two completely separate cloud providers or two separate implementations. And the reason that you would do that, right, is that, you know, if you're a company and you're, you're exposing some of your most critical business services, right, you want to know that they'll continue to function.
Yeah.
One of the most common complaints that you hear whenever there's a disaster is that a company had a disaster plan or a disaster recovery plan, and when they tried to actually execute it, they couldn't because some ism or issue or something that no one had accounted for. Which is usually just that they didn't actually build it that way and test it on a regular basis. So nowadays we can actually take a blueprint like this stock trading application, and you can see here that we actually have part of it running in Cloud A, part of it running in Cloud B, and simply by starting this, we'll actually go out here and provision this app into these two different clouds, sync them up, and basically put it online so that users can begin to consume it.
Look, we've been on this journey for 5 years now, and what was initially just an idea has sort of blossomed into a fully fledged way of now focusing on delivering IT as a service. So I do think we're quite mature. In fact, I would say we're a market leader in what we're doing from the enterprise side, and we're very proud of that.
I think the common vision is emerging. The ECLC is a very important part of this puzzle because it provides the buy-side expertise and viewpoint as to how these environments should emerge over time.
There's a broad cross-section of participants, all of whom have a shared vision of being able to have an end-state model and architecture that really starts to be able to realize some of these objectives. But everyone comes with slightly different experience, slightly different approach, slightly different agenda.
The opportunities really are just starting to form, and it's great to be part of an organisation that's trying to take advantage of that.
We joined the ECLC for two reasons. One was to be with like-minded customers and enterprises on the buy side. The second part is also to have a forum in which we can put out our requirements, to write out some reference architectures, and to create and to generate even some controversy around this is how we think the industry is going to be. What do you think?
The IT as a Service reference implementation from the ECLC represents the work of so many companies and vendors that have come together to make this happen. It's actually an amazing outpouring of support around a common vision. VMware, Cisco, EMC, BCE, Microsoft, Puppet Labs, Virtual Clarity, Service Mesh, a company close to our own heart. So many companies that have come together to really listen to what the enterprise is saying and try to show something that manifests that, but in a very practical way that other companies can follow. We should have a shout out to the companies that actually spent the time and effort to put forward their vision and to consolidate it and to offer input of what this should really look like. Visa, American Express, Bank of America, UBS, CBA, Pearson, and others. Of course, I want to thank you, Anthony, for all the time and effort that you put in, and I think you'll be available as well in France at the TM Forum Management World to show everybody the reference implementation and the theories behind it and answer any questions that come up.
Why this conversation is so relevant to everyone on a global scale is the quicker and faster we can innovate products, the more healthy our economy will be. What we're seeing now is this evolution of the IT organization from a cost center to really being a growth driver of revenue for major companies.
This is not really an IT discussion anymore. This is a discussion about the nature of competitiveness at the business level. Those of us that are hoping we're making a difference in this field are now walking hand in hand with the CEO and the shareholders to actually change the way that the competitive posture of the company is perceived. And it's very exciting.
The dot-com bubble was all about Silicon Valley and websites, but it didn't change for 90% of companies their business model. This is going to change their business model, and we've not seen something like that since actually the dawn of technology.